For the today's lab class, we are going to see three-phase bridge inverters. So three-phase bridge inverters, it is a six-step voltage source inverters. Already we have seen the different types of inverters. There is voltage source inverter and current source inverter in single phase. So it is a type of voltage source inverters, and it is a six-step voltage source inverters. The output voltage waveform has 6 steps, and the circuit has 6 SCRs. 3 are from positive group and 3 are from negative group, and step means it is a change of firing from one SCR to next SCR in proper sequence. So for a 360 degree waveform, we will have 6 steps of 60 degree each step, and the modes of operation are 180 degree conduction mode and 120 degree conduction mode. The 180 degree conduction mode means each SCR will conduct for 180 degrees, and in 120 degree conduction mode, the conduction period of each SCR will be 120 degrees. So it is a typographical mistake. So in 120 degree conduction mode, each SCR will conduct for 120 degrees. So this is a circuit diagram for the three-phase bridge inverters. So we can use SCR or any self-commutated device. So the second circuit will shows that it is the IGBT. We are using IGBT as the switch for the three-phase voltage source inverters. And first one we can see the 180 degree conduction mode. So as the name implies, each SCR conducts. That is the conduction period of each SCR will be 180 degrees. And the upper group are the positive group and the lower group are the negative group. That is the numbering will be important. That is upper group are the 1, 3 and 5, and lower group are the 4, 6 and 2. That is upper group plus 3 will be the lower group. S1 means S1 plus 3, S4. S3 means S3 plus 3, S6. And S5 means S5 plus 3, S8. That is totally 6 SCR. So 8 minus 6, that will be 2, S2. So the SCRs, that is suppose we are taking S1 means that will conduct for 180 degrees in 180 degree conduction mode. So that is SCR from same leg conduct at an interval of 180 degrees. That is S1 will conduct for 0 to 180 degree means then S4 will conduct from 190 degree to 360 degree. So that is shown over here. And the SCR from upper group conduct at an interval of 120 degrees. So between the each phases there will be a phase difference of 120 degrees. So S1 will conduct at 0 degrees, it will start the conduction, and S3 will start the conduction as 120 degree, and the S5 will start the conduction at 240 degrees. Similarly for the negative group of SCRs. So this is a conduction sequence for the 180 degree conduction mode. So this is a conducting sequence. We can draw the table. That is a conducting sequence table. That is, there are 3 phases. First phase will have, that is A phase, or the here it is mentioned as A phase, or we can make it as R, Y and B phase. So for the A phase, the SCRs are connected to the A phase is 1 and 4, and the B phase is 3 and 6, and for the C phase is 5 and 2. So each phase will have some conducting sequence. So depending upon that, we are drawing the conducting sequence table. That is for the first one, A phase, the conducting SCRs are 1 and 4, for B phase 3 and 6, and for C phase 2 and 5. So the first phase, A phase, the T1 thyristor will conduct from 0 degree to 180 degree. That is, it is a 180 degree conduction mode. So the first SCR will conduct from 0, start the conduction from 0 and finishes its conduction at 180 degrees, and the T4 thyristor will start its conduction at 180 degrees, and next it finishes at 360 degree. Similarly, from 360 degree to next 180 degree T1, and another again the cycle will repeat T1, T4, T1, T4 each for 180 degrees. The next one, the second phase, that is B phase, the T3 thyristor will start its conduction at 120 degrees. Since between the phases there will be a phase difference of 120 degrees, so T3 will start the conduction at 120 degrees. So 120 plus 180 up to 300 T3 will conduct, and from 300 to plus 180 the T6 will conduct. So if are limiting up to single cycle, that is 360 degrees, 300 to 360 T6 will be conducting, and before T3 for a period of 120 degree the T6 will be conducting. Then next third phase, So from the first phase, the third phase will have a phase difference of 240 degrees. So the positive group of SCR T5 will start its conduction at 240 degrees plus 180 will be 240 to 360 plus 0 to 60 degrees. So here we can have two conduction periods, that is 240 to 360 degrees, that is 120 degree conduction, remaining 60 degree from 0 to 60 degree, and T2 will be conducting from 60 degree to 240 degrees, 60 plus 180 240 degrees. So it will conduct from 60 to 240 degrees. So for each step, that is we will have up to, for a single cycle we will have 6 steps. For each step, that is for each 60 degrees, 3 SCRs will be conducting. The 3 SCRs will be 2 from the positive group and 1 from the lower group, that is negative group, or 1 from the positive group and 2 from the negative group. So likewise it will be conducting. So for the step 1, the first group of thyristors, the first conduction thyristors are 5, 6 and 1, and the second step 6, 1, 2, third step 1, 2, 3, and fourth 2, 3, 4, fifth 3, 4, 5, and 6, 4, 5, 6, and again this cycle repeats. So depending upon this we can calculate the voltage. So first sequence, that is for step 1, the conducting SCRs are 5, 6 and 1. So from the diagram we can see the odd number thyristors are connected to positive, so that it is called positive group, and the even numbered SCRs are connected to negative, so that it is considered as negative groups. So if it is a odd numbered means it is positive, and if it is even number means it is connected to negative. So for the first step, 5, 6 and 1, that is 5 and 1 are connected to positive and 6 is connected to negative. So here this is the first one will be the circuit diagram. So in the circuit diagram, the first one and one, so this is the first thyristor, and 6 will be conducting and 5 will be conducting. So 5 and 1 are the positive group of thyristors, so that will be connected to positive. 6 will be the negative group of thyristors, it is connected to negative. So first is corresponding to A phase, 6 will be corresponding to B phase, and 5 will be corresponding to C phase. So the A phase and C phase are connected to positive and B phase is connected to negative. So this will be your equivalent circuit. So from the equivalent circuit, A and C phase are connected to positive, and A and C phase are connected to positive and B phase is connected to negative, and each phase will have an impedance, that is a load impedance of Z. So this is your neutral point. O is nothing but your neutral point. So with respect to neutral point, the A phase and C phase are connected to positive. So we can we can measure the voltage across each phase, that is the phase voltage, that is VA naught, VC naught and VB naught. So VA naught will be Vs by 3, that is from this we can calculate, that is Vs by 3, so that we can study in detail in the theory class. So here total voltage will be Vs, and here two branches, Z for A phase and another Z for C phase. So here one branch, that is Z for the B phase. So from this we can measure. So this is your VA naught. So this is VA naught, and it will be equal to VC naught. So VA naught is equal to total voltage Vs into the voltage division principle, that is Z divided by total impedance. So this will be two parallel impedances, that is Z into Z plus Z plus Z, Z into Z divided by Z plus Z, that is Z square by 2Z. So Vs into Z square divided by 2Z divided by total impedance will be Z plus So this term, that is z square by 2z will be, so z will get cancelled, z by 2, so here it will be z by 2. So Vs into z by 2 divided by z plus z by 2, so it will be, we can take LCM, so 2z plus z, 3z by 2, that is Vz into z by 2 divided by 3z divided by 2. So this will be z, 3z by 2, so 2 will get cancelled and z will also get cancelled, so finally we will get Vs by 3. Similarly, we can measure the voltage across VB0, that is VB0 is equal to, here Vs total voltage into the impedance, that is Z, divided by the total impedance will be Z plus Z by 2, that is 3Z by 2. 3Z by 2. Here the Z will get cancelled, so we will get 2 Vs by 3. So Va0 will be equal to Vc0, so that will be equal to Vs by 3, and Vb0 will be equal to 2Vs by 3, and it is connected to negative, so that it will be minus 2Vs by 3. Similarly, for the all the steps we can calculate the voltages. So for 6 steps we can calculate, finally we will get the voltage like this. So Va0 will be for first step Vs by 3, 2Vs by 3, again Vs by 3, then negative, that is minus Vs by 3, minus 2Vs by 3 and minus Vs by 3. Similarly, for the 3 phases we can calculate. So these are the phase voltages Va0, Vb0 and Vc0. Then line voltage we can calculate, that is Vab is nothing but Va0 minus Vb0. So Vs by 3 minus of minus plus Vs 2 Vs by 3, so 3 Vs by 3, that is will be equal to Vs. And for the remaining cases also we can fill the table, that is these are the line voltages table. So line voltages we can fill. So from this we can draw the waveform for the phase voltages 3 waveforms and line voltages 3 waveforms. So this will be your phase voltage waveform, that is Va0. First it will be for 0 to 60 degree, it will be of Vs by 3, and 60 to 120 2 Vs by 3, 120 to 180 plus Vs by 3. So here it will be Vs by 3 for 60 to 60 degree, and again 2 Vs by 3, and again here Vs by 3. So this will be for half cycle, and it will be repeat in the negative half cycle. And Vb0, so first term, that is 0 to 60 degree, will have minus 2 Vs by 3, again minus Vs by 3. So here it will be minus 2 Vs by 3 for 0 to 60 degree, and again here that is plus, that is minus Vs by 3. Here it will be the magnitude of minus Vs by 3, again plus Vs by 3. And for the C phase we will have first one plus Vs by 3, and again for second step we will have minus Vs by 3. So here plus Vs by 3, and here it will be minus Vs by 3. So this will be minus Vs by 3. So from this we can easily draw the waveform, that is it will start from Vs by 3 to Vs by 3, again Vs by 3, and it will be repeated in negative. So the second phase will be 120 degree delay of the first phase Va0, that is here it will be starting at the 120 degrees and the cycle will repeat. And for the C phase it will start at 240 degrees and the cycle will repeat. So this is the phase voltage, and this is the line voltage, that is Va0 minus Vb0. So from the table we can mark, that is for first 120 degrees it will be Vs, again 0, again for 120 degree minus Vs, again 0. So here we can see for 120 degree it will be plus Vs. So this will be the magnitude of plus Vs, and for 120 degree it will be plus Vs, and again for 60 degree it will be 0, and again another 120 degree it will be minus Vs. Similarly for all the phases we can draw. So this is 180 degree mode. So this 180 degree mode we can plot it in PSIM. So in PSIM we will have the 6 SCRs, or we can have 6. Here I am using IGBTs. So for IGBTs we are having 6 IGBTs, that is for T1, T3, T5 that is positive group, T4, T6, T2 are the negative groups, that is connected to negative. So from the table I have shown, you can fill the conduction periods. So here for the first phase, that is from the conduction sequence, you can see the T1 will start the conduction at 0 and finish the conduction at T1. So here the conduction, so this is 120 degree mode, this is 180 degree mode. So T1 will start the conduction from 0 to 180. So here we will give the firing pulse for 0 to 180 degrees, and again for the negative group it will be 180 degree phase difference, that is 180 to another 180 degree it will conduct, that is 360 degrees. So T1 will start the conduction 0 to 180 and T4 will start the conduction at 180 to 360. So between these two, T1 and T3 will have the phase difference of 120, and T3 and T5 will have the phase difference of 120, that is totally 240. So here it will start the conduction at 120 plus 180 degree it will conduct, that is 180 degree conduction mode. So 120 plus 180, 300 degrees. So again from 300 it will conduct for 180 degree, that is T6 will conduct for 300 plus 180, that is 300 plus 180, 480. So limiting it for a single cycle, so 300 to 360. Again remaining 120 degree will conduct from 0 to 120 degree. So this we can take it from the conducting sequence. So here we can see T3 will conduct for T, that is 120 to 300, and again T6 will conduct for 300 to 360, and again here 0 to 120 degrees. So this will be marked over here. And similarly for T5 it will start the conduction from 240 to 360, and before here it will be 240 to 360 means it will be 120 degrees, and remaining 60 degrees from 0 to 60 degrees. So there are 4 conducting points, that is 0 to 60, 240 to 360. Similarly for T2 will have, so before this the conducting transistors are T2, that is before T5, T2 will be conducting. So it will conduct from 60 to 240. So 60 to 240. So these 2 resistors will have 4 switching points. Remaining all the 4 the SCRs, 4 the switches will have 2 switching points. So here we are having the input voltage as 100 volts, and we are giving the firing points, and we are having IGBTs, and we have to change the values over here. For each device we have to change the frequency as well as switching points. 50 Hertz frequency and switching points we have to make it with respect to the conducting sequence, and the load resistance will be 10 ohms for each phase. Here we are using only the resistance, that is 10 ohms, and these are the voltage probes, that is VAN, VBN, VCN are the phase voltages, VAB, VBC, VCA are the line voltages. So on running this we have to place the simulation control, that is for 2 cycles we are displaying, or 2 cycles we are running the simulation. So on running this we will get, first we can see the phase voltage VAN, then next one VBN, and the third one VCN, right? So this will be your phase voltage for the 180 degree conduction mode. So 180 degree conduction mode we are having the voltages. So here we will have Vs by 3. First step will be Vs by 3, that is 100 by 3, 33 point VAN we can see 33.33, and 2 Vs by 3, that is 2 into 100 by 3, that is 66.66. Then third step will be again 33.33. So similarly for negative, that is minus 33.33, minus 66.66, and again minus 33.33. Similarly for the remaining 2 phases VBN and VCN we will have 6-step waveforms. Vs by 3, 2 Vs by 3, again Vs by 3, again minus Vs by 3, minus 2 Vs by 3, again minus Vs by 3. So there are totally 6 steps. So for each phase we will have a 6-step waveform as your phase voltage. And the next one we can run it for line voltage. So for line voltage we will have VAB and VBC, then third one VCA. So this will be your line voltage waveform. So for 0 to 120 it will have the magnitude of 100, that is Vs, again 0, again minus Vs. So similarly for the all the remaining two phases, remaining two line voltages, we will have this will be the 100 volt and this will be minus 100 volt. In between 60 degree there will be 0 voltage period. So from this we can derive. So first one 0 to 120 Vs and is 120 to 180 0, and 180 to plus 120, that is up to 300, it will be minus Vs, and 300 to 360 again 0. So this waveform is starting at 0 degrees and this will start at 120 degrees, and the third waveform will start at 240 degrees, and again the cycle will repeats as the same first waveform. So this is the 180 degree conduction mode. The next one we can see the 120 degree conduction mode. So in 120 degree conduction mode we will have the SCR, each SCR will conduct for 120 degrees. So this will be the 120 degree conduction mode. So the same circuit diagram, and so each SCR will conduct for 120 degrees. So remaining all the things will be same, that is 1 and the difference between the upper length 1 and 4 will be 180 degrees, and 1 and 3 will be 120 degrees. Phase difference it will be starting. So the conducting sequence is first phase 1 and 4, second phase 3 and 6, third phase 2 and 5. So first phase the positive group are the positive group of SCRs are the 1, 3 and 5, negative group of SCRs are 2, 4 and 6. And the first phase, the T1 will start the conduction at 0 and it will finishes at 120 degrees, and remaining 60 degree no devices will be conducting, and T3 will start at 180 degrees and it will finishes 180 plus 120, that is 300. Next 300 to 360 there will not be any conduction of devices, so it will be the 0 conduction devices period. So for next is a second cycle, second phase, the 120 degree T3 will be starting, 120 plus 120 up to 240 it will conduct, again 240 again over 60 degree it will be 0 conduction period, again 300 to 120 degree, 300 plus 120 420 the T6 will be conducting. So limiting it for a single cycle 300 to 360 T6, and again remaining 60 degree from 0 to 60 degrees. Then next one we can have the third phase. The T5 will start the conduction, that is positive group of the T5 will start the conduction at 240 plus 120 360 degrees, and next one 60 degrees it will be 0 conduction period. So before this also 0 conduction period for 60. So the T2 will conduct from 60 to 180 degrees. So for each step we will have 2 SCRs will conduct at a time, one from the positive group and another one from the negative group. So in the previous case 3 SCRs will conduct at a time. So here 2 SCRs will conduct for each step, one from positive and one from negative. So here we can easily calculate the voltage of each waveform. That is here first the conducting SCRs are 1. So here the conducting SCRs are 1 and 6. The remaining phase, third phase, there will be no SCRs conducting. So 1 is connected to positive and 6 is connected to negative. That is A phase is connected to positive and B phase is connected to negative. So it will be the neutral. So with respect to VA neutral, VA naught will be equal to, so this will be a neutral, the VA naught will be equal to Vs by 2. So it will be 2 devices means, so the, it will be half of the voltage. Vs is a input voltage, and for VAN it will be, or VA naught it will be Vs by 2, and VB naught it will be Vs by 2. VC naught will be 0 since no devices are conducting from C phase. And similarly for the remaining steps we can calculate and we can fill the table. So for each step 2 SCRs will be conducting. So first VA naught it will be Vs by 2, Vs by 2 and 0 and minus Vs by 2 for another 120 again 0. So for each step we have to calculate and fill this table. From this we can easily predict the waveform. So the VA0 will have plus Vs by 2, 0, minus Vs by 2. So totally there are three magnitudes, 0 or Vs by 2 or minus Vs by 2. So it is a quasi square waveform. So here VAB, that is line voltage. So these are the phase voltages and these are the line voltages. So line voltage will have different magnitudes. That is VA0 will be, VAB will be VA0 minus VB0, Vs by 2 minus of minus Vs by 2, that is my Vs by 2 plus Vs by 2, that will be equal to Vs. So this Vs, and again like this we can calculate Vs by 2 minus Vs by 2 minus Vs and so on. And similarly for the next phase VBC and VCA we can calculate. So the waveform will be like this. VA0, VB0, VC0 will be the quasi square waveforms, and VAB, VBC, VCA line voltages are the stepped waveforms. So this thing also we can realize in PSIM. So for 120 degree conduction mode we will have the circuit like this, the same circuit. We have to change only the firing angles for the each SCRs. So from the table we can, or from the conducting sequence we can have, that is T1 will conduct from 0 to 120, T4 will conduct from 180 to 300. So likewise we have to fill 10 to 120 for T1, 180 to 300 for T4. So we have to change the frequency 50 and the switching points 180 to 300. Similarly for the second phase 120 to 240 for third T3 SCR, and again 60 T6 SCR will conduct for 0 to 60 and 300 to 360. So T3 120 to 240 and T6 0 to 60 and 300 to 360. So likewise the third phase will be T5 will start it from 240 to 360 and T2 from 60 to 180. T5 240 to 360, T5 240 to 360, T2 60 to 180. So here all the phase voltage and line voltage probes are connected, and we have to run for 2 cycles. So if we run means, so first thing we have to close all the things, and we can run for the only the 120 degree conduction mode. First we can measure the phase voltages VAN, then VBN, and third one VCN, right? So here we will have the voltage of Vs by 2, that is 50. Here it is minus 50, and VCN will be 0. And then next we can measure the phase voltage, already we have measured. The next we can measure the line voltage, that is VAB, it is a 6-step waveform, and VBC, and third one will be VCA. So that will have the magnitude of Vs by 2 minus Vs and minus Vs by 2 and minus Vs again minus Vs by 2. So this will be the first line voltage, that is VAB, second one will be VBC, third one will be VCA. So likewise we can simulate the 3-phase voltage source inverter for 120 degree conduction mode and 180 degree conduction mode. Thank you.